Hey everybody, this is question number 10 on the chapter 9 individual assignment. This one's a little bit harder than some of the others because we're using formulas that we haven't really had to use to this point, and we kind of only use them for these beta problems, finding the beta. So I have the two formulas up here that you'll need. You can also find those in the book. This formula is on page 416. Anyway, so let's start with what we know. We know that the value of our proportion for our null hypothesis is 0.15. So I'm just going to call that our null. Okay, that is the proportion of the null, or pH0. So this number right here. We also know that n is 134. Our sample size. We know that alpha is 0.05. And we're also going to need our p, which will be our actual proportion at some point. So we're going to get there. So p for this problem is 0.18. So we can see here, looking at this formula, so this is called the p alpha, or the critical proportion for a hypothesis test. So in order to find this, we're going to need our p null, which is this number. We're going to need our critical z, which we haven't calculated yet, and then p null, and then n. So I'm going to go ahead and do the critical z. That's going to be norm.s.inv, and for the probability, 1 minus our alpha. All right, so now that I know all that information, I can go ahead and calculate my p alpha, or my critical proportion. Again, that formula is on page 416. So I'm going to say this equals my null proportion, or my p of h0, plus, and I'm going to use plus because this is a right-tailed test. I would use minus if it's a left-tailed test. My critical z times square root of my null times 1 minus my null divided by n. So there's my p alpha, or my critical proportion. The next thing I'm going to need to find is the z value of that critical proportion. So I'm just going to label it as z, and I'm going to use this formula here. And it's actually not the z value of the critical proportion, it's the z value of our actual value of p given this critical proportion, okay? So we're going to say this equals our critical proportion, or our p alpha, minus our actual proportion. I'm going to actually put that in parentheses. And then divided by the square root of p times 1 minus p divided by n. So there's the z value of a p of 1/8, so a proportion of 1/8 with a critical proportion, or a p alpha, of 0.20. So finally, to find our beta, we just need the p-value of this z-score. And if you remember how to do p-value from earlier in the chapter, it's just going to be norm.s.dist, put in our z-score here, and true, and that's going to be our beta. So it says 4 decimal places, So that's 0.7339, so 734. Then it wants us to do the same thing, but for when P is 0.22. So I'll plug that in there and it will, now that our calculator is working, we can just do 0.2952. And that's it. So I know it's a little scary because it's a new formula, but once you know the formula, you can create your calculator and you'll be in good shape. So good luck on the question and have a great day.